Hello all. Today 8051 has a timer mode explained briefly. In that timer, there are uh, two timer used in that 8051. Timer 0 and timer 1. Timer 0 and timer 1, there are four modes. Mode 0, mode 1, mode 2, mode 3. Mode 0 has a 13-bit timer and mode 1 is a 16-bit timer. And mode 2 is 8-bit, but it is auto reload mode in timer, means value is automatically reload. And mode 3 is a split. Two 16-bit timer as a split, TL higher and TL lower, TH and TL bit. And in that mode 3 use, timer 1 will be inactive mode, and same as a timer 1 mode. These four modes are same, and mode 3 has a only change, timer 0 will be inactive. Next is when a timer timing program, then timer register required, which is TCON register and TMOD register. TMOD for timer mode selection and TCON for timer as a timer or counter. When timer has a external supply, then it is count as a counter mode, and when timer has a internal pulses, then it count as a timer. Register TH0, TL0 for mode, timer 0 mode, TH1 and TL1, it will be timer 1 register, high and low byte. TH is a high byte and TL is a low byte. We turn timer 0 mode 1 millisecond delay using timer 0 with interrupt approach. In that interrupt approach, timer 0 is a frequency of a timer. 8051 is running at a 12 megahertz crystal, so and require a 12 clock cycle. So divide by 12 by 12, 1 megahertz means 1 microsecond, 1 megahertz frequency to the timer, and 1 microsecond has a 1 millisecond has a 1000 microsecond. So in that maximum count to the timer 0 mode in that 2 raised to 13 bit. 13 bit is a timer mode 0 use. So 2 raised to 13, its maximum count is 8192, and that is maximum delay generated in one count, one shot count, 8.192 millisecond. Greater than 8.1 microsecond delay generate, then repeated that low count and store that, so use that value and looping that delay. Case 1 microsecond delay generate, that 8192 minus 1000, 7192 is a final count, and this count will be loaded in one first load higher register, then lower register, split in 8 bit. So then simplest for user, I am only count variable and th will be this count is maximum count uh, in loaded count shifted by 5 and with 0xff. This that means load in 01, then load in lower byte count and with 0x1f and shifted by right shift by 3 bit thanks to the lower 5 bit registers. Then start timer working when timer start from 0 or given value from th or tl load. Then go to the last count of the timer. They'll go to the 8192. So in that generation delay, we start from timer 7192 and end from 8192. That means delay generation is 1 microsecond. Now these are registered required to the timer application interrupt approach. TH0 and TL0. This is simplest logic for only store the count, not exactly find the which count load and hexadecimal split as 8 bit. Then Tmod register 0x0 denoted to the timer mode as a 0 and mode 0 operation, means 13-bit timer use. Then enable timer interrupt and enable global interrupt, and then start the timer and check the flag of TF flag.